4 astronauts just came home from the moon, and almost nobody understands what happens next. 2 days ago, the Orion capsule hit the Pacific at 25,000 miles per hour and splashed down right on schedule. Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen are back in Houston. The mission is over, but the race is just beginning, because what NASA is planning for the next 2 years is more aggressive, more technically demanding, and more historically significant than anything this agency has attempted since the 1960s. 3 crewed missions, a lunar landing for the first time in over 50 years, and the beginning of a permanent human base on the moon's south pole, all of it hinging on hardware that has never carried a single astronaut to the lunar surface. So let's break it all down. What just happened? What comes next? And why the clock is already ticking? Artemis II launched on April 1st and spent 10 days proving that Orion can keep humans alive in deep space. The crew swung around the far side of the moon. Passing within 4,000 miles of the surface, they photographed terrain no human eye had ever seen directly. Craters, mountains, geological features that previously existed only as orbital data. They broke a 56-year-old distance record, reaching over 252,000 miles from Earth. That record had belonged to the crew of Apollo 13 since 1970. Jeremy Hansen became the first Canadian to travel beyond low Earth orbit. Christina Koch added another first to a career already defined by them. Victor Glover became the first black astronaut to fly to the moon. And in a moment, nobody predicted when the mission was originally scheduled. The moon drifted between the spacecraft and the sun. The crew witnessed a total solar eclipse from beyond the moon itself, totality lasting nearly 54 minutes. Victor Glover said it looked unreal. By every measure, the mission performed. But there is one problem that did not go away. When the first Artemis mission flew in 2022 unmanned, Orion's heat shield came back damaged in ways nobody had predicted. Chunks of charred material had broken away during re-entry. The shield still protected the spacecraft, but the damage pattern did not match the computer models. Engineers were nervous. For Artemis II, NASA changed the re-entry approach to reduce the stress on the shield. The crew came back safe, but mission managers confirmed after splashdown the damage was there. Again, divots cracking, uneven ablation across the surface. NASA knew this was a possibility going in. They flew the mission anyway because the underlying structure would hold, and it did. But the problem is not solved. It is being studied. A redesigned heat shield formula is already being built into the next 2 capsules. The question now is whether the data from this re-entry, combined with Artemis I, gives engineers enough confidence to move forward without another unmanned test flight. That answer determines the entire schedule from here. Here is where most people's understanding of the program breaks down. Because Artemis III is not what you think it is. For years, Artemis III was supposed to be the landing. 2 astronauts descending to the lunar South Pole aboard SpaceX's Starship lander. A week on the surface, the whole thing. That plan has changed. In early 2026, NASA delayed the landing to no earlier than 2028. Then, just 5 weeks later, NASA's new administrator pulled Artemis III forward to mid-2027, but stripped out the lunar landing entirely. Instead, Artemis III will fly for astronauts to low Earth orbit aboard Orion, where they will rendezvous and dock with the commercial lunar landers. SpaceX's Starship Human Landing System and Blue Origin's Blue Moon Lander, both launched separately on their own rockets. The crew will physically enter the landers, test propulsion systems, evaluate life support, check communications, and try on the new Axiom spacesuits that future moonwalkers will wear on the surface. The comparison NASA keeps making is Apollo 9. In March 1969, astronauts flew the lunar module in Earth orbit for the first time, testing, docking, practicing spacewalks in the suit that would walk on the moon 4 months later. Apollo 9 never gets the glory of Apollo 11, but without it, Apollo 11 does not happen. Artemis III is that mission. Unglamorous, essential. There is a significant challenge sitting right in the middle of this plan. Neither lander has ever flown with humans aboard. SpaceX's Starship HLS needs to reach orbit, then be refueled by at least 14 separate tanker flights from a pre-positioned propellant depot that SpaceX also has to build and fill. Each tanker flight uses another Starship. The logistics of moving that much liquid methane and liquid oxygen into orbit, transferring it between vehicles that have never done orbital fuel transfer at crew-rated scale, is an engineering challenge that would have seemed impossible a decade ago. Blue Origin's Blue Moon takes a different approach, more conventional in some ways. But it has also never left the ground with astronauts on board. Both companies must complete uncrewed lunar landing demonstrations before NASA allows crew inside. A recent Inspector General report noted those demonstrations will not be fully representative of the crewed vehicles. That means the first time either lander carries astronauts in its final configuration may be the actual mission. If neither company is ready in time, NASA has a serious problem. Artemis III without a lander is just another Orion flight. Assuming the lander tests succeed, everything shifts to Artemis IV, early 2028, the first crewed lunar landing in 56 years. 4 astronauts fly to lunar orbit aboard SLS and Orion. A commercial lander, Starship or Blue Moon, will already be waiting there, having launched separately and positioned in an elliptical polar orbit. Orion docks with the lander. 2 astronauts transfer inside and descend. For the first time since December 14, 1972, human boots press into lunar soil. The landing site will be near the Moon's South Pole, a region no human and very few robots have ever visited. The South Pole is nothing like the flat equatorial plains where Apollo astronauts walked. This is a place of extreme terrain, long shadows, and violent temperature swings. At the floors of certain craters near the pole, sunlight has not reached in billions of years. Temperatures drop to nearly 400 degrees below 0 Fahrenheit, and trapped in that cold, according to orbital instruments, is water ice, possibly a large amount of it. That ice is the reason NASA chose this region. Water means drinking water for astronauts, oxygen to breathe, and when you split it into hydrogen and oxygen, it means rocket fuel. The South Pole is not just a scientific destination, it is a potential gas station for everything that comes after. The 2 surface astronauts will spend approximately 1 week on the Moon. They will conduct spacewalks, deploy a seismometer to map the Moon's internal structure, and collect samples from a region never touched by human hands. Then they ascend, dock with Orion, and ride home. Total mission duration, roughly 30 days. The longest Apollo surface stay was 3 days. The jump in complexity is enormous. Before the dust from Artemis IV's landing has settled, NASA wants to go back again. Artemis V is targeted for late 2028. This is where the language changes. This is where NASA stops talking about missions and starts talking about a base. Artemis V will be the second crewed landing. 2 astronauts will descend to the South Pole aboard Blue Origin's Blue Moon lander. They will have a rover, the first time astronauts have driven on the Moon since Apollo 17 in 1972. But the real purpose of Artemis V is construction. Robotic cargo landers will have already pre-positioned power systems, communication arrays, and mobility platforms on the surface. Artemis V's crew will be the first humans to interact with that infrastructure activating equipment, connecting modules, verifying that the robots did their job. NASA's administrator has called this the first phase of a 3-step plan. Build, test, learn, then add semi-habitable infrastructure, then sustained presence, crews rotating through a functioning base every 6 months, living and working on the Moon for weeks at a time. The target for continuous human habitation on the Moon is 2032. By then, NASA envisions long-duration surface missions, nuclear power systems keeping the lights on through the 14-day lunar night when solar panels are useless, and crews using lunar soil itself as a raw material for construction and oxygen extraction. The Moon stops being a destination and becomes a factory. There is a geopolitical dimension to all of this that most coverage glosses over. China's lunar program is moving fast. They have already landed robots on the far side of the Moon, something no other country has done. They have returned samples from the lunar surface. Their stated goal is a crewed landing by 2030, with their own permanent base to follow. If NASA's timeline holds, American astronauts land 2 years before China gets there. If the schedule slips, and with programs this complex, schedules almost always slip, that margin disappears. The Lunar Gateway, that orbiting station NASA had been planning for years, has been cancelled. The money and engineering talent is being redirected toward the surface base instead. Modules originally designed for the Gateway are being repurposed. The focus is the ground, not orbit. The SLS rocket itself nearly died in 2025, when a budget proposal called for cancelling it after Artemis III for several months. The program's future was genuinely uncertain. Legislation passed in mid-2025 kept it funded, but But the episode revealed how fragile the political foundation is beneath a program this expensive. Every election cycle is a potential extinction event for Artemis. None of this is guaranteed. The heat shield needs to work with its new design. The landers need to fly. SpaceX needs to solve orbital refueling at a scale nobody has attempted. Blue Origin needs to deliver a vehicle that has never left the ground. Congress needs to keep funding a program that costs billions per year. Every single link in this chain has to hold. But standing here, 2 days after splashdown, the picture is clearer than it has been in years. Artemis II proved Orion can keep for humans alive in deep space and bring them home from lunar velocity. It proved the Space Launch System works. It proved the European-built service module can travel nearly 700,000 miles round-trip without a critical failure. Every system that future crews will depend on to reach the lunar surface has now been tested with people inside it. That did not exist 2 weeks ago. The question was never whether we could get back to the moon. We just proved we can. The question now is whether we can stay. If this breakdown helped you understand what comes next, subscribe, because in 15 months, another crew climbs into Orion, and after that, the landings begin.